Find a net dipole moment for the system shown in the figure. So in the diagram it is given, here is charge minus q, here is charge minus q, here is 2q, so it's an equilateral triangle of side length L. So if it is equilateral triangle, each angle will be equal to 60 degree. So we need to find the dipole moment. Now to find dipole moment, what I will do, I will split this charge 2q into plus q along with this charge and another plus q along with the charge on the right side. Now it forms two dipoles. One dipole moment will be this way, other dipole moment will be this way. So remember, dipole moment is always directed from negative charge to positive charge. So this is one dipole, this is another dipole. So let us call dipole moment of this is P1, dipole moment of this is P2. So the net dipole moment is vector sum of these two. So one dipole moment P1 is this way, but this is P2. P1 is this way. They are acting at 60 degree. Now what is P1? So we know that P1 is equal to Q into L. P2 is also equal to Q into L. So net dipole moment P is equal to vector sum of P1 and P2, right? So net dipole moment magnitude is given by square root of P1 square plus P2 square plus 2P1 P2 cos theta. Now angle between these two, theta is given, it is 60 degree. Now substitute and simplify. So P1 is Q into L. So it is Q into L square plus Q into L square plus 2 into Q into L into Q into L into cos of 60 degree is half. So what happens? It will be root of QL square plus QL square plus this will become QL square. So it will be 3 QL whole square. So that will be root 3 times Q into L. This is the net dipole moment. Right? Coming to direction of this, direction will be along the angular bisector. It will be this way. Both are equal in magnitude and it will be acting at 30 degree to each of them. So this will be the resultant dipole moment. Magnitude is root 3 QL. So direction is vertically upwards in the diagram.